Okay, my friends, we're back again. Dynamics rectilinear motion example number 1, okay? We've got a car, I don't know, it could be a particle. Anytime you think about something like this, if you want to consider it a particle, just think about its center of mass. It's not rotating, it's going to move some direction, okay? Now this particle we have is defined by this equation. It's given us velocity of 6t minus 3t squared. Okay, so with that looks parabolic to me, which means that it could move this way for a minute and then it probably moves backwards, right? So this is going to be a parabolic motion here, looking at that equation. They tell us at time 0, the displacement is 0, okay? So this thing is going to start off, let's just call this the origin, and it's going to go out to some point. Now, if the time is long enough, it may go out and it may come back. I don't know if it's long enough or not, but let's see. Find the deceleration and position when t equals 3 seconds. Find how far the car has traveled during those 3 seconds and find out what the average speed was. Okay, so let's see if we can do that. So we're given this equation here. So find deceleration. Now deceleration is acceleration, right? This really is acceleration, okay? But it's probably just going to have a negative sign in front of it, right? Deceleration is like negative acceleration. So let's use the acceleration equation. Let's use this thing here. Okay, so A is equal to dv dt, okay? And what is that? dv, that is the derivative of the velocity with respect to time, okay? Do we know how to take derivatives? Of course we do. So let's take the derivative of velocity, which is this thing, 6t minus 3t squared, right? We'll do dv dt on that guy, right? dt. Okay, so what is the derivative of that business right there with respect to time? Well, this portion here, right, a equals, that just turns into a 6. And you remember how to take the derivative of this, right? You're going to reduce this by 1 and we'll multiply that coefficient there by the exponent. So that's going to become minus 6t, okay? So there's an equation for acceleration at any time. So what time do you want to use? Well, they say find the deceleration in the position when t equals 3 seconds. So if we put a 3 right there, what do we get? The acceleration is equal to 6 minus, what is that guy, 18? Which is equal to minus 12, and that's going to be meters per second squared. Okay, so that is the acceleration. That is A. For at time 3 equals time equals 3 seconds, right? So that's the deceleration. Obviously the negative tells us it's decelerating. Now they want to know the position. How do we know the position when t equals 3 seconds? Well, let's see. We can do that too, can't we? Because we know position is up here, isn't it? Okay, so position is like v is equal to ds over dt. That's position, so let's get that by itself. Let's say that ds is equal to v dt, okay? And then we want to get that by himself, so let's just do the integral of both. And we know what v is, don't we? V is equal to that, right? So ds is equal to 6t minus 3t squared dt, right? Now to get rid of those ds and dt, what do? We just integrate both sides, right? So this one goes from 0 to s, or from 0 to the final position. And this one goes, with respect to t, 0 to t, right? That's time t over there, okay? So let's see if we can we integrate that? Well, this just becomes s, and this over here becomes, we need to integrate that. So that becomes 6t squared over 2 minus, what does that become? 3t cubed over 3, right? So my 3's are going to go away. That's going to go into there about 3 times, and I'm going to left with s equals 3t squared minus t cubed. So now I have an equation for that particle's position at any time. Okay? So let's see. What can we do with that information? Okay? Next. Well, let's just see where this particle is at 3 seconds. Let's put a 3 in there. So S is equal to 3 times 3 squared minus 3, 3 cubed. That wasn't good, was it? Okay, let's see. 3 squared is 9 times 3 is 27, and 3 cubed is 27, so that's equal to 0. That says it never went anywhere. Oh, wait a minute, what does that say? Here's what it says. Here was the car. He went out, and then he slowed down, and then he came right back. Maybe he went out, stopped, and then put it in reverse and accelerated right on back, right? So basically what we're saying here is the car is where it started. So at time, the deceleration at 3 seconds was negative 12 meters per second. So he's speeding up as he's coming back this way, right? But at 3 seconds, he's back where he started from. So the position is 0, okay? So 0 equals S at t equals 3 seconds, right? So how far has the car traveled during the 3 seconds? Well, let's see. What would the velocity be at that point right there? You know what I think the velocity would be at that point right there? I think it would be 0. And when could that? Let's look at this equation up here for velocity. Let's factor that, shall we? You know what I think I can get out of that? I think I can get a 3t, and then what else can I get out of that? That's going to make a what? 2 minus t, right? Is that right? That becomes 6t, and that becomes 3t squared. So that's right? So when would v be 0? Well, when t is equal to 0, right? So at time 0, v would be 0. And then from this, how would I make that thing 0? At 2, right? So 2 minus 2 is 0. So what is that telling us? That the velocity is equal to 0. The velocity was equal to 0 there. And the velocity was equal to 0 there at t equals 2 seconds. Okay? And at 2 seconds, could we find out how far our particle traveled? Right here is an equation for particle travel right there, isn't it? So how about this? S equals, let's put a 2 in there, 3 times 2 squared minus 2 cubed. What is that? That's 4 times 3 is 12 minus 2 times 2 is 4 times 2 is 8. So that's 4 meters at 2 seconds. So that says that thing moved out there 4 meters, right? And then it moved back 4 meters. So the total amount of travel during the whole 3 seconds was how much? 4 and 4, right? The total amount traveled, 8 meters. What was the average speed? Well, you went 8 meters, right? It took you 3 seconds to do it. So that must be 3 into there goes 2.67 times, and that's meters per second. And that would be your average speed. There you go. Is that too hard? Kind of tricky, but not too bad, okay? So we're using our relationships that we developed in our last video, okay? Let's do another one, see if we can do another example, okay?